For this particular problem, we're going to be finding the region, but the shade is not given, so we have to be a little more careful. So in this one, we're trying to find the area of the interior of r equals cosine theta. Now, hopefully you're getting more comfortable with this kind of stuff now. If I were to plot r equals cosine theta, what I know is that the center would be at 1/2. It would go all the way out to 1. That tells me that this has a radius of 1/2. So we know that a circle with a radius of 1/2 is going to have the area pi r squared, which is 1/2 squared. So we expect our answer to be pi over 4. But we're not going to do that with just standard geometry, because what we're trying to do is we're trying to prepare ourselves to do this for things that may come later where we can't just use standard geometry. So with that in mind, what we'd like to do is use this formula here, that the area is 1/2 the integral from the starting angle to the ending angle of f of theta squared d theta. Now, an important consideration here is that this is only valid in the case where the function is non-negative. So the outputs of that function need to be positive radii, not negative. And I'll show you why that's important. So if I'm starting out, remember we always start our theta at the 0 point. So if we always start going along the theta equals 0 line. So we see that we start, and it's positive, right? Because as we go, it starts from here, comes out to 1. And as we continue to go up an angle, we have positive values, right? So it starts at 1, and it gets a little less, a little less, a little less, a little less. Keeps going. And finally, it's going to shrink down to 0. The distance from the origin to that point is going to shrink down to 0. Now, here's your problem. If you continue on, so my angle is going from 0 to pi over 2. But if I continue over here, if I go to 3 pi over 4, I actually end up having to go negative. So instead of being pointed in this direction, I have a negative r. Well, that invalidates this theorem. I can't use that because as I go to this angle, I get a negative r. Well, that's not helpful. So what I should do instead, instead of this angle rotating up like this, what happens if I rotate it down? What if I go to negative pi over 4? Well, I notice if I go to negative pi over 4, it comes out. So if I go through these angles and I'm viewing them as positive angles and negative angles, I end up with a positive radius every time, or a positive distance, or r value, every time. So why is that important? Because then as I go from 0 down to pi over 6, pi over 4, pi over 3, so on, so on, so on, my radius gets smaller and smaller and smaller and smaller back to 0. So I've covered this whole circle by saying that I go from negative pi over 2 to positive pi over 2. So by doing that, then I can set this integral up and we can solve for it. I say, all right, my integral is 1/2 negative pi over 2 to positive pi over 2 cosine theta squared d theta. Now, a very common thing you're going to do here is you're going to use the double angle identity. We're going to end up with 1/4 negative pi over 2 to pi over 2, 1 plus cosine 2 theta d theta. When I take the antiderivative here, I'm going to get 1/4 theta plus 1/2 sine of 2 theta from negative pi over 2 to pi over 2. Now you get lucky here because you're going to get 1/4 pi over 2 plus 1/2 sine of pi minus 1/4 negative pi over 2 plus 1/2 sine negative pi. Well, sine of pi and sine of negative pi are both 0. So this gets me 1/4 pi over 2 times pi over 2 minus 1/4 negative pi over 2, which is pi over 8 plus pi over 8, which is pi over 4, which of course is what we expected, right? The whole point of doing this is not to do something new and fancy, right? Or rather not to get a number, because we knew how to get the number. It's easy. We know how to get the area of a circle. The key is to practice the principles of this so that when we move to things that we don't understand, we have a better handle around it, and we can do some mathematical modeling to figure out how to draw these angles to get a meaningful answer.